All right, moving on to a different type of weathering, chemical weathering. Chemical weathering, remember, it changes the actual minerals in the rock so that afterwards the rocks are smaller, but they're also slightly different. Oxidation is the first type. Oxidation has the word oxygen in it, and that's when free oxygen combines chemically with metallic elements in it, usually iron, and you might get rusting. And you can see in this picture over here, this rock is rusted, and that weakens the minerals in the rock and breaks it apart. Oxidation does turn rocks that rust-colored red, and it's weakening the rocks in the process. Carbonation, another form of chemical weathering. Water contains carbonic acid naturally, just carbon dioxide dissolved in the water, and all rainwater is slightly acidic because of this. And carbonation usually affects areas that have calcite minerals, anywhere where there's lots of limestone, bedrock, perhaps marble. It definitely affects limestone and marble gravestones. You can see in this picture over here, you can hardly read this thing. You go into a cemetery and you read two gravestones, one granite and one limestone or marble, and you can hardly read the marble if it's an old gravestone, and really old granite gravestones are still in great shape. So big difference because of the minerals involved. Caves, lots of caves in this area are formed by carbonation. The groundwater, the slightly acidic groundwater, dissolves the limestone bedrock, opening up caverns, slowly depositing these stalactites of calcite and stalagmites on the bottom. And there's your stalactites and stalagmites. This kind of shows how caves form. You get water filling in, dissolving the limestone bedrock, and the water table lowers throughout, long time periods. And then you get your caverns, your caves are left over. And this is a picture inside one of our local famous caves, Howe Caverns. Some cool pictures here. Never forget the boat ride as a kid. All right, another type of chemical weathering. We got hydration. Occurs when water combines with minerals, most often in granite, forming mica and feldspars. This eventually breaks down into clay. So water plus granite over time makes lots of clay. And it's because of the feldspars breaking down. Now you can see here, water did get into the cracks in that mud, that clay there. And then when the water dries up, it leaves cracks, which open it up to other kinds of weathering. So it's a self-speeding up process once again. Okay, acid rain. Here we go. Acid rain, big problem in the Northeast because of all the coal-fired power plants to our west. The prevailing winds carries those sulfates in our direction, and some of the nitrates too. And then we end up getting slightly acidic rain, which eats away at the rocks, kills the fish in our lakes that aren't buffered with any kind of calcite. But you can see how it's just totally destroying these wonderfully carved marble features. Even Cleopatra's Needle in New York City is suffering because of acid rain. On the side that faces where the prevailing winds come from, you can see it's really, really, really worn down. On the side that's away from the prevailing winds and rain, it still looks pretty good. But if it was back in Egypt, it would look a lot better. So it takes its toll on everything. Chemical weathering also can produce a feature called sinkholes, with lots of those in Florida. Karst topography is what this is called. It forms caves, caverns, and sinkholes especially. Form of chemical weathering. There's this nice sinkhole. Not so nice if you're the homeowner, but that rock underneath was pretty much dissolved away by the slightly acidic groundwater. Some areas have lots and lots of these sinkholes. Everywhere you see water there is a sinkhole. The making of a sinkhole. This picture just kind of shows the whole process of how groundwater gets moved around. So in this case, there's a well pumping out the water, so that reduces water pressure. The water comes up there. Caves form when water dissolves limestone in the aquifer. So this water is slightly acidic. It's dissolving the limestone bedrock away, leaving those caverns there. Vibrations from new construction can have issues in this. And you know, eventually the ground, which was right here, has nothing to support it anymore and it caves in. So that is just a brief picture showing how sinkholes might occur in places like Florida. Lots of limestone bedrock there. All right, guys, sorry for the long lesson, but we had a lot to do to start this unit out. And now it's time to start your homework.